Good afternoon, everyone.
Hi, Robbie.
Just give it a couple of minutes before we get started, see if there's anyone else waiting to join.
Hi, it's Christina.
Hi, Christine.
Hi.
Good afternoon, this is Daniela.
Good afternoon. Right, okay. Right, I think I'm going to get started. We've got 30 people joined. I'll keep on checking just to see if there's anyone else in the lobby. So welcome everyone, and thanks for joining us in our second session in our open series of design sessions. Just before I get started, I'm going to place everyone on mute just to cut out any background noise and interference. So that should be done now. Also, the call will be getting recorded for those who cannot attend, people who've got other commitments. So I'm hoping that no one's got an issue with that. There will be a link to the recording, and the slide deck can be issued and emailed out to everyone afterwards. Okay, just before we get started, let me introduce myself. My name's Robbie Hodson. I'm going to be mediating the session. My role for Glass Futures is as project engineer for the St. Helens plant, which is what this presentation is based around. Won't go into too much detail on that now, as we do cover it in the slides. If you did attend the first session, you are going to get a couple of slides repeated at the beginning, just the introduction slide. So I appreciate your patience to go through those slides again. It's very important to us at Glass Futures that people can be interactive during this and ask questions, and your input is very important. So during the questions and answer sessions, if you can, raise your hand using Zoom, or that'd be great, or use the chat option, and we will answer your questions at the end of each topic. So before we get onto the full agenda, I'm going to pass you over to our Chief Executive, Richard Katz, to say a couple of words, and then he's going to pass over to Rob to start the presentation. Rob, I'm going to give you control of the screen now, and over to you, Richard.
Good afternoon, everybody. I hope you can hear me. Can somebody confirm? Robbie?
Yes, yes, that's fine. I can hear you fine, thanks.
Thanks. Okay. This is part of the evolution of Glass Futures. As an entity, we started seriously last January 2020. So we've only been going 13 or 14 months. But during that period of time, our aim to start off with is the delivery of zero carbon methods of manufacturing glass. And I have to say that some of this has been taken a little longer than we'd like to see in terms of recruiting our personnel, our expert personnel, but we're now up to, I think, 15 personnel, all of whom are experts in their spheres of activity. And over the course of the last month, we have also had the good fortune of working very closely with one of our members. Just to remind you, we're a membership organization, not-for-profit membership organization, and we've had the opportunity of working specifically with one of our members to test out over a course of a 3 to 4 week period a total alternative energy source to that of natural gas. And this has proved very successful indeed. We've been running on a sustainable biofuel over this 3 or 4 week period, producing many tens of millions of bottles. And we now know for sure that we're well on the right road to delivering our aim, ultimately, of a global cooperation for an alternative fuel source to natural gas. It won't be the same fuel source for every producer of glass, but we know that we can now know that we can develop specific types of production processes for virtually all elements of glass. It's early days, and we're still having applications for membership coming in, and we welcome all prospective members for discussions, different types of membership for different applications. As I think people know already, we have 5 UK universities in membership. But this particular program today is covering the post-production element, really, digitization, forming, annealing, and quality. We're very fortunate that we do have some world experts on this to talk, but the overall program today will be handled by my colleague, Rob Arson, who's our Innovation and Partnership Manager. So Rob, can I hand over to you?
And thank you very much, Richard. So I'm just trying to get onto the next slide. Let's see if it's working. It's always fun with these technology platforms, isn't it? Yeah, so I think just like to echo Richard and Robbie's welcome. It's great to see so many people here today. We do appreciate your time. I'm conscious of how busy everyone is. So thank you for attending. Hopefully the agenda will load up in a moment, but have an action-packed afternoon. We've got squeezing in quite a lot of different things in the next hour. If we can actually get onto the next slide, Robbie, it's not quite working, but maybe you can switch.
It does say you're in control, Rob, but
I've got the circle of death, unfortunately. Anyway, so just in terms of the agenda for the afternoon, I'm going to give a quick introduction to Glass Futures and our St Helens pilot plant. And then we've got 2 industry experts presenting this afternoon. We have Tobias Facman, who's going to be talking to us about digitalization technologies. And then we have Peter Firth, who's going to be sharing his experience, there we go, on forming and annealing technologies and automatic inspection. Just in terms of the, yeah, it's not, sorry about this. It's always the case. It worked fine in rehearsals this morning. It's might be worth you taking over, Robbie, in terms of the slides.
okay.
I mean, anyway, in terms of standard bits of information for the session, there we go. Would like to just to flag up that this is a public open meeting. So we do have a antitrust, anti-competition and competition law policy. So if we touch on any commercial topics in this session, we will have to stop the session. So I would please ask everyone to refrain from touching in those areas. And if anyone feels that we are infringing on those areas, please do flag it up and we can either end the session or steer away from them. It's something to take very importantly. The other thing to note on that line is confidentiality. So this is an open session. So it's not governed by any confidentiality agreements. So please do not share anything that might be sensitive during this session. If there are topics that you want to discuss that might be confidential, then more than happy to have arrange a separate session under NDA to discuss those. And also just in terms of how the session will run, as you saw from the last slide, we've got a series of presentations, and then we've got question and answer sessions after each of those presentations. So I would ask everyone to remain muted throughout the talks. And then if you do have questions, either raise your hand during the question and answer sessions themselves, or alternatively, you can just put the question in the chat and we'll make sure we pick those up in the question and answer sessions. Let's go on to the next slide, Robbie.
Yeah.
So just going to start by introducing Glass Futures. Conscious that many people around the screen will already know a lot about Glass Futures, but there will also be many who don't know as much about us. So the heart of Glass Futures is what we're trying to do is we say we are co-creating a global centre, or the global centre of excellence for glass. So the heart of what we want to do is we want to make glass the low carbon material of choice and increase its use throughout society. Now, key phrases within that are co-creating. So it's not something that the Glass Futures team are creating on our own. We are working with industry. And when we say industry, we mean industry, supply chain, end users, and anyone else who's working in the area of glass. So it's really a collaborative platform. And we want to be the global centre of excellence as well. So we're not just UK based or even European based, but we want to service the whole global glass industry. We see that as important to achieve our goals. And it's only by working with that global platform that we are going to achieve our objective of making glass truly the low carbon material of choice. In terms of what that collaboration looks like, it comes in a number of different flavors, so to speak. So in some levels that will be private. So we might just be working with one or two specific manufacturers on certain developments, but it might also be in larger collaborations as well, maybe even industry-wide. But at the heart of what we want to do is really to take those kind of ideas, or to even kind of catalyze and generate those early stage ideas, and basically fast track them through to commercial reality as quickly as possible and as efficiently as possible to maximize the impact. So what we're really keen to do is have a real kind of commercial edge to the research we're doing. We're conscious that often a lot of research can kind of get stuck in academia a bit, and often then become slightly detached from industry needs. But within Glass Futures, we want to kind of effectively bridge that gap between academia and industry, and really kind of speak a language that both sides can understand, so that we can kind of utilize the strengths of all the parties involved and really try and deliver some of these kind of step changes that industry needs to deliver if we're going to hit some of the targets that we need to achieve, such as the trying to decarbonize by 2050. In terms of values, we are a not-for-profit company, so we're not a glass manufacturer, and we don't want to be a glass manufacturer. We are primarily there to drive research and development. We also want to be open access, and again, our funding streams mean that we're obliged to be open access. So that means we can't have any favourites. We can't kind of close our door to certain parties. Our membership is open to everybody, and that is a transparent membership. But at the same time, we do have great respect for confidentiality and IP. So we're very conscious that a number of the developments that we will be involved in will have significant value to individual members or parties. And we basically have set up systems within our organisation so that we can protect that IP or that information to specific parties or specific projects. So just because someone works with Glass Futures doesn't mean that every member gets to find out about what's being done. It just depends on the type of research, who's contributing to it, and how the project's been set up. So it is possible to have projects just with one member if that is necessary. And then in terms of IP, so we will generate IP, but our remit is really to generate IP for members. So there might be times when Glass Futures owns that IP, but generally our preferred route is for us to help our members generate that IP. We're not a commercial entity that wants to kind of suck IP for our own benefit. We will only hold that IP if it can then create value for the members.
Okay.
Can I have the next slide, please, Robbie?
Yeah.
So I think that if it's going to come up. So the I think the next slide is basically kind of outlines the UN Sustainability Development Goals. So I don't know how many of you have come across these before, but these are basically goals that have been sort of identified sort of by the international UN. So it's kind of seen as the goals that are required by our kind of all of our society, really, if we're going to tackle the problems that our society is facing. And I was really excited, I think, when I saw these, just to realise how many of these different boxes that glass actually touches as a material and as an industry. So there's some obvious ones in there. So I don't know if you can read it. It is a little bit small, but for example, box 9 talks about industry, innovation, and infrastructure. So obviously that's at the heart of what we want to do, as well as things like the box 12, which is talking about responsible consumption and production, as well as things like the box 13, climate action. But actually, as you look through the others, if you kind of step back and look at how glass products interact with everything we do in life, you see that actually glass does underpin a lot of the other areas, or certainly influences other areas as well. So for example, if you look at box 11, you've got sustainable cities and communities. Well, just look at things like the advanced glazing systems and the impact that has on reducing energy of buildings, for example. Then box 7, you've got affordable and clean energy. So we know that glass plays a key role in applications such as solar panels, glass fiber composites in wind turbines, that at the heart of generating renewable energy. And even some of the functional glass products. So you can make glasses that do have all sorts of interesting functionalities, like antimicrobial, for example, and that also can contribute towards improving the health of society, or even sort of encouraging kind of cleaning systems for water and things like that. So actually, as you look at it, glass really does play or have a key role to play in terms of creating a sustainable society. And I think within Glass Futures, we have this fantastic opportunity, not just to make the manufacturing process of glass more sustainable, but actually to really have that impact on society as well, particularly when you look at some of the initiatives we've got in terms of training and development on top of the sort of just developing glass as a material in its own right. And then kind of aligned with that, obviously, to achieve those goals, we're not going to do it if it's just a few companies working on their own. We're only going to have this impact, and we're only going to achieve this vision and achieve or deliver the potential that glass has to change society if we all work together. So we do need to come together as a global industry to address these issues. And that's kind of at the heart of what Glass Futures wants to be. We want to be that kind of platform, that global platform, that global hub where all these different groups can kind of come together and meet. You can kind of facilitate that cross-pollination of ideas, of expertise, of opportunities to really kind of address some of these and make the difference that we can. So yeah, I hope that kind of gives us a flavour that Glass Futures isn't just about trying to improve the furnace. Glass Futures really is about developing the full potential of glass. The other thing I'd like to stress is Glass Futures is more than just a pilot facility. So I know we've had a lot of publicity about the pilot facility, which I'll talk about in the next slide. But it's also key to be aware that actually Glass Futures is getting involved in a whole range of other research activities alongside the pilot facility. So for example, many of you will have heard about our industrial fuel switching project. One of our key aims as Glass Futures is to identify new fuels that can replace fossil fuels, basically decarbonize the glass manufacturing process. We're also looking at developments into new raw materials. For example, can we replace existing raw materials with materials derived from waste streams in other sectors? Can we increase the amount of recycled glass that can be used in glass manufacturing to reduce energy, to reduce CO2 emissions? Can we develop new furnace technologies, new burner systems, new waste heat recovery systems? So Glass Futures is already involved in projects in each of those areas and is looking to expand that project portfolio. One thing I would state there is that there's all sorts of opportunities for others to get involved in those projects. So already through the projects that we've managed to secure funding for, we've managed to secure hundreds of thousands of pounds of grant actually for our members as well as for Glass Futures. So again, that's certainly a great opportunity which we'd encourage everyone around the screen today to engage with. How can Glass Futures help you basically to get some grant funding to deliver your research needs? And then training is also at the heart of what we want to do. We realise that if we're going to deliver these technologies and deploy them across the global glass industry, we're going to have to help the industry develop new skills and train up new people to come into the industry and attract new people into that industry. So again, that is something we're working heavily on at the moment within Glass Futures, and that will also be the theme of our next session at the end of next month as well. And then on the right there, you can just see the kind of the key themes or selection of the key themes we're working on at the moment. So I've already mentioned the alternative fuels, but also keen on things like the circular economy and looking at things like new digital technologies, Industry 4.0, which Tobias will be introducing to us later on. So if I could have the next slide, please, Robbie.
Yeah.
But as I said earlier, the sort of at the heart of what we're doing, one of our kind of core projects within Glass Futures is the development of the pilot facility at St. Helens. So for those who aren't familiar with what we're trying to do there, so we have basically secured a significant amount of funding from government, that's both national government and the regional government from the Liverpool City region, as well as in-kind pledges of support from industry itself. So this is the total investment into this plant is approximately £54 million. And what we want to create here really is a state-of-the-art, fully flexible pilot facility that certainly in the first phase can produce up to 30 tonnes per day, but that has space to expand, hopefully to build a second pilot line in the future as well. This facility is still in the design phase. So this is one of the reasons for these meetings, is just to make people aware of what we're doing there and aware of the opportunity for everyone to get involved in helping to design this facility. So if that's something of interest, please do get in contact with the Glass Futures team. We'd love to get as many people as possible involved in the design of this facility. Because what we want to do is we want to make sure that every single bit of this facility has the opportunity to trial the new state-of-the-art technologies of the future, be it from the furnace itself through to new emission systems, so things like waste heat recovery, carbon capture, through to the kind of downstream processes as well, things like forming, sensors, new coating technologies, for example. The idea is that this will be a fully flexible line that can provide a space to trial all of these technologies. I think it's also worth saying that the line will also be set up to trial different fuels as well. So as well as natural gas and electricity, we're also designing the facility so it can run biofuels as well as hydrogen as well. So hopefully it really will be the factory of the future. And then actually the other point to note is, as well as the physical asset being factory of the future, we're working very closely with partners such as Siemens to make sure that actually the digital infrastructure is of the future as well. So we want it to be that real kind of demonstration where people can come to the site, they can see these new technologies being trialed and implemented, and they can actually get involved in those developments themselves. Thanks, Robbie. So that was quite a whistle-stop introduction of Glass Futures. So just going to pause there for a few minutes to see if anyone has any questions on what I've said so far.
There has been one question coming from Neil Butler. Don't know if you want to unmute yourself, Neil, and ask the question to Rob direct, or do you want me to ask the question?
No, that's all right. No, it was just a thought that, you know, a lot of us on this meeting, a lot of people involved in Glass Futures are by definition glass people, and we might want to be as flexible in our thinking as we possibly can. But let's take the glass industry as a whole. A lot of us have been in it for a very, very, very long time. So we have baggage and we have preconceptions. So my question was really, is anybody from the wider packaging industry, say, for example, involved, so that they can think about, without any baggage on what glass can and can't do, they can think about glass as a new material and say, right, how can we make it lighter? How can we change the shape? Just as I unmute, I got a phone call. How can we change the shape? What can we do with packaging as a concept, you know, to negate the rise and effort that's not negate, but to compete with the rise and effort that's going into these coated paper technologies, etc., that are being publicized as well. So it was just to see that is, you know, outly tackling that side as well, from the consumer and market driven side as well as the technology.
Yeah, no, thanks for that. That's a great challenge, and that's the sort of challenge we want within Glass Futures. So we are addressing those kind of questions. So this is why we want sort of to involve the full supply chain and academia in that as well, just to try and get as many different perspectives to understand what the opportunities that are out there. So for example, some of the work we're doing within the academics at the moment, we are exploring routes to look at new forming technologies. Can you do something to kind of the forming process to try and improve that sort of, or the different ways of making the bottles? Can we do like a one-step forming process, for example? What options are out there? So we're certainly considering that and working out not just what the opportunities are, but then how can we actually start to investigate those and drive those through. But then as well as the academia side, we also are working with many industry experts as well. So likes of Peter Firth, who we'll get to see later on. Again, he's got a huge amount of experience of actually making the bottles. And I think the strength of Glass Futures is we actually can provide that platform where someone that's totally new, who has some really interesting out of the box concepts, can come and meet someone like Peter, who actually has to make it happen in real life and can kind of share ideas. And then alongside that, we can bring in people like the brand owners, the likes of Diageo, Heineken, those kind of groups we're keen to draw into Glass Futures as well. So we kind of get the end user perspective as well. So it's not just something that might be lightweight, that's practical, but it's actually something that the customer actually wants. So it's trying to get all those different parties together to feed in at the early stage to then progress, not just progress the developments, but actually get to a solution that someone wants at the end of it. Does that answer your question, Neil?
Yeah, no, that's fine. Thank you very much.
Yeah, have we got any more questions before we move on to the next topic? No, I'll move on. Rob, do you want to introduce Tobias?
Yeah, sure.
Thank you.
So thanks, Robbie. So yeah, I'm just going to introduce our next speaker. So Tobias Facman began his career at Siemens in 2000. He's held numerous sales positions within Siemens in the Cologne branch, and then in 2012 he moved to the Siemens Process Industry headquarters in Karlsruhe, where he also worked on behalf of many glass customers before moving to the vertical glass and solar division in 2017, where he was responsible for product development, digital development. Mr. Facman then took over as head of vertical glass and solar on the 1st of June last year. This afternoon, he'll be giving us an overview of how end-to-end digitalization technologies can help revolutionize the glass sector. So thank you very much, Tobias, for joining us, and I'll hand over to you now for your presentation.
Thanks to Europe, and thanks for having me to Glass Futures. I hope you can hear me loud and clear. Okay, great.
Yeah.
So it's a really pleasure for me being here because as you maybe had heard in the introduction, it's a passion. It's my personal passion in glass, and it's our job and our passion in order to stay in contact with people on sites in the glass manufacturing area, which is quite tough right now due to the current situation. At least we can exchange some ideas and information here on a virtual way. So again, it's a pleasure being here and having this talk, which I'm sure we wouldn't have had maybe 3 years ago, at least in this detail and in this relevance to the glass industry, as Richard explained. So there's a kind of evolution going on. I think all of us are used to quite dynamic slideshows, so I can promise you, at least for my part, to stay with one slide. So you will have a chance to get familiar with this slide, and I would bring you guys at Glass Futures in trouble in order to move on. So you can see to the left kind of storyline from which I will go along, divided in 3 main areas. You can see an overall picture. I'm talking about the value chain, not only about the value chain in the glass manufacturing, but as already Neil mentioned, the value chain is longer to both sides. The second one will be dedicated to more the glass production area, and the third one about technologies in general. To the right, you can see a slide. Maybe I have to unveil the source here a little bit because I think it's not mentioned. So this is taken from our slide set hold on the Virtual Glass Tech, October last year. You will find it as video with detailed information on our web page, siemens.com/glass. And I was pretty glad to see it yesterday in the Glass International session from Systricam. They used exactly the same picture. So what is this picture about? If you're reading the headline, end-to-end digitalization, this is our mission from ourselves, Siemens, with our own factories, as well as providing solutions for the different industries where we have a focus on the glass industry as well. So this is about automation, where we are pretty used to, I think, from the past, but quite interesting area and increasing area is the industry software area, where we had a dramatical, so the highest growth, so to say, in the past 10 or 15 years, portfolio-wise, so what we can provide to the industries. And on the other hand, we have quite some chances and opportunities in the industry in order to use this software. and of course services in order to connect, interlink, and address these both areas through the complete value chain of a production area. Going into the picture, you can see 3 layers. So starting from the bottom, I would call it blue, but at home I will get into trouble talking about colors. So this is what we call real plant, covering the different steps of production area with a batch house, with a hot area, with a cold and logistic areas, but again, other areas as well, like processing. The second layer, which is more important at that point, is the virtual production area, talking about Industry 4.0 digitalization. This is where you can make the difference. This is where simulations will happen. This is where you will find digital twins of equipment, digital twins of data, of machineries, of plant areas. And I think the question is, why should we do it? Or why should we follow this train of thought here? And creating a virtual environment of the real plant. This would help to extract the performance data out of the plant in order to check for improvements, to run some optimizations without influencing the real plant. You can do some or embed some training systems on this area where you can train operators, train people, and where you can check for abilities to implement for new products. And this is exactly the third layer. I would call it light green, where maybe we can discuss about where the supply chain begins. Because the demands of new products, the demands of innovations, the demands on having a higher flexibility, maybe with, unfortunately, lower quantity of products, comes from the customers of the glass manufacturing industry, which could be food and beverage, which could be pharmaceutical, which could be healthcare, whatsoever. And this is where the demand and the requirement for new products starts. And where the glass manufacturers has to act more flexible, use innovations, and trying to cope with this. So maybe you can imagine to exchange these product designs via data files, handle it on this virtual product layer in order to optimize the product on the base on computer-aided engineering tools, fluid and flow simulation tools, optimize the weight of a product, optimize the material, optimize a quality or reach a certain quality of a product, and then try to bring it on the second layer, the virtual plant, in order to check if this is able to be produced on this real plant, if there had to be some modifications going on and had been or will be necessary in the plant. And all of this is possible without influencing the real plant, and lower the yield and take this out, lower the availability of the plant. So this is the overall picture, and even additive manufacturing could be a possibility here in order to create the new design product, having a look and match of it, then create in the forming area new possibilities which hadn't been able to manufacture before. And for all of these things, you need virtual, or it would be at least helpful to have a virtual area of machineries, of automation, and interlink all of these possibilities. So the second use case along the value chain is on the other hand, on the other end of the picture, from the consumer itself, where I think Richard has mentioned it, zero amount of carbon. So the footprint of the product itself matters. And therefore, of course, you have to ensure or try to reach a lower energy amount of a plant to reduce emissions. But as well to find some tracking and tracing opportunities and abilities to tell the customer the product that you are using and you would like to buy had been produced with this footprint of emissions, energy, and so on. And this is going along the complete value chain. And how would it be able to do this tracking and tracing? This is getting to data. So data sourcing, data should be available. We are talking about providing the right connectivity here in a plant, which is on a vertical way from a sensor or from an actor communicating straight to above layers of the plant, maybe even to a virtual production plant and a product. In order to do some predictions of maintenance to ensure the availability of a plant, and on the other hand, to have horizontal connectivity, a horizontal integration of a plant, where data could be linked together from a hot end to a forming area to a cold end to logistics area, and so on along the value chain. So these are pre-requirements in order to implement advanced solutions here, to implement plant intelligence systems, to provide the right transparency, to do maybe data analytics, use artificial intelligence applications, and maybe to do some predictions in order to, would it be able to produce this good? What would be the production like in 2 months' time, in 1 month's time, depending on economical data, depending on historical data, to predict the availability of the plant, to predict what maintenance would be necessary in order to keep the plant up and running. So this is what you can do and what we are already doing in the plants to increase the connectivity. And talking about the third part here, technology is step change. So our experience is talking to the customers at the last production, as I said, or already mentioned 3 years ago, it would have been a totally different picture. So I would say that last production manufacturing area is on the move to a digital factory. Of course, it's not there, but it is important to collaborate here in order to find the right measures to go this way together, to find the right approach, the right roadmap for digital transformation. Because quite some amount of money, I've heard a figure like 900 billion euro had been spent on digitalization efforts without any results, without any value. So it is really necessary to, we are talking about brownfield very often. What is the realization? What is the vision? And what is the gap in between in order to find the right way here? So we are on the move, but we have to decide carefully what would be the right way. Grade of monitor and control. So I think we can see it today. The grade of automation, the grade of monitoring is quite important, as I mentioned, to connect different areas of the plant, maybe connect the customers along the value chain, or connect the consumer on the other hand. So a lot of things are going on and are possible. And I hope that Glass Futures will be able to go that way and do the best and most out of it in order to provide the right levers here, showing what could be ease of use, showing what would be the right tool and the right handling in order to attract the required workers and people, to ensure that we can run our plants, or you can run your plants out there, and that these employees do have the right tools. Operator training systems could be one of these because from my experience, people are not staying that long as before as a trainee up to retirement. So there's a job change going on where operator training systems on the base of virtual production areas can help. And I'm convinced that we are not able to cope with all of these situations on our own, providing a solution. It's collaboration, as Rob mentioned here. He's partner management. So we should connect each other. We should find our way together and collaborate here. So I think time is over. I got 10 minutes. Robbie is getting nervous there. So the best of luck for Glass Futures, finding this right way, do the most out of it, finding the right interaction of systems, so to say, integrate digital twins, all of these possibilities. And if we can help and support there, let me know. Thanks.
Yeah, thank you very much for your time today, Tobias. Does anyone have any questions for Tobias?
Tobias, I've got a question. Tobias, this is Ajit from Glass Futures. Tobias, what are the two big challenges you face in relation to digitalization?
One of the two big challenges we face, it's about convincing that that this could be the right way, and this has to be the right way. Other way, you will lose the contact, and you wouldn't be able in midterm to provide the right product in the right amount of money. And the big challenge is to find the right lever here. So this would be a second one, not just starting with something, rather finding the right point where you have to start, and then find the right priority, which measures had to be taken in which direction. So one is dare to do, and the second one is to find out which would be the way.
Thank you, Tobias. There's one other question as well. If a glass manufacturer wanted to convert their existing line to a digital line, what would be the best starting point? What kind of skills do you think the glass industry needs to develop in order to take advantage of these technologies?
Yeah, it's again, you have to analyze what is there, what is the situation. It's not everything that we are able to do some greenfield like Glass Futures, starting from scratch. So to detect what is the real plant about, what opportunities, possibilities are there to connect all of these ones, so plant networks, security, to regard all of these different required steps, and to think about what would you like to reach. Yeah, what is the target, and then to decide what is the situation, what is the target, what could be necessary in between. And of course, it's connectivity we are talking about.
Thank you. One final question from Rogerio. Are artificial intelligence concepts being applied to digitalization, and how do you identify data bias when using it?
Oh, there are numerous of artificial intelligence sets. So we did something in the processing area of a float glass to improve the set to run the machine properly. Yeah, so analyze historical data. This is the usual way. Find out what would be the right set for a typical product, for the typical quality, and so on. So the possibilities are there. Sometimes data are not there. So it would be good to have this data available. Would be okay to have it in different systems. At least you need data. Without it, you couldn't do something. You can do artificial intelligence, as we did at Siemens at one plant, to predict what product will be ordered in 1 week time or 2 months time, in order to have a prediction of orders, or a prediction of what product should be produced next and after that one. So there are really many possibilities that we can cover with artificial intelligence.
Okay, thank you very much. Right, I'm just conscious of time, so I'm going to move on to our next subject. Thank you for your question, Rogerio, and thanks again for your time, Tobias. Our next subject will be forming. So our next speaker is going to be Peter Firth. So before we move on to these next topics of forming, annealing, and automatic inspection, let me just give you a quick brief bio of Peter. Peter started work in the glass container industry straight from school. His career started with shop floor working and eventually progressed through to plant management. Whilst working in the glass industry, he's gained both a bachelor's and a master's degree, both at Sheffield. And he worked at Ardagh Glass, forming best practice development within the operational excellence group. He's now working as a consultant for Glass Futures on the St. Helens project. Peter, I'm going to try and hand control to you to see if we can get this to work. So,
okay, thanks, Robbie.
If you click that, that should be in your control.
Yeah, can you see the mouse?
No.
No?
No. Can you just click the mouse again?
Yeah.
Yeah, you should be in control now. Yeah.
Okay. Right. Excuse me. So yeah, you can see the mouse around the working end area there near the furnace, yeah, just to double check.
Yes, you can, yeah.
Yeah, good. Okay, so I don't think we've got too long left, but on this session, but I want to just explain to you the production area concepts. We've got some ideas what we want to do, what we think is the right thing to help the industry in terms of development of new systems. But what I can say, you know, at this stage, this is fully flexible. So if you've got any input, we're very happy to hear that, and we'll try to integrate that. We really just want to serve the R&D side of the industry, like's already been explained. And so really what we're looking at here is a facility that's geared more towards supporting R&D than it is towards supporting highly efficient production, which is mostly what I've been used to all my life, trying to strive towards 95% plus efficiencies, etc. But in this case, we'd be happy to cull it all day long, and you know, as long as it supports R&D. So if I can just explain to you this diagram, first of all, if you look to the left here, okay, so you can quickly forget this area, so it become a less complicated drawing. This is a plan view, of course. We can see the furnace here, we can see the working end here, these are the powerhouse, these are the machines, and this is the layer. But to the left there, you can forget that. We've just put that in for a future machine. Not saying it's going to be an IS machine, but we've gone worst case for loading calculations for the plant. That could be any other kind of forming machine. But at the moment, if you just look where we've got the green, that's what we're intending installing. Certainly and definitely to the right there, this forehearth, we're looking to install and to feed one machine. Now, the one machine that we're looking at currently, what we're proposing to do is put a 10-section bed in there with 6 operational sections. And the reason for that is we've got space at either side then to run development work on new forming processes or forming sections. And they don't have to be the standard 21-inch. You know, we've got more space there, so we've got 42 inches to play with there either side. So also the height of that is important. We've got a 6-meter metal line height. That means you can get monitoring equipment in quite easily for work on the gob, monitoring the gob, or whatever you want to do after you've cut the gob before it enters the scoop. So there should be plenty of room there. Then what we've looked to do is create, let's say, a reasonably long conveyor, not over long. The challenge that we've got is this is only going to be 30 tons. So the production output is going to be quite slow, but we need some room on the hot end conveyor to support things like hot end vision inspection development and other kinds of inspection. So, and also possibly coating hood. We might have a second coating hood development work going on. So we want plenty of space on this conveyor, but then we've only got a low output of a machine. So that will bring its challenges, and yeah, we have to look at how we can overcome that. Then also what we look to do is support glass conditioning development. At the moment we're showing a K48, but in all likelihood it's going to be much smaller. So we put the worst case, largest forearth in for loading purposes again. But what is key to what we're doing as well is putting this late stage introduction section in here. So a colorant section, probably know it more for colorant, but we could do late stage compositional modification here. So here would be the introduction point, and here would be the mixers. And then we have another powerhouse, and this is yet to be defined. We wanted a second point that we can draw off glass, of course, so we can keep the glass flowing through the furnace if we're doing any refractory changes here. But as yet, we're although it looks like it's feeding this machine, in fact it's not. That would be the feed point for that machine. This would be for flat glass. Typically, we would want to draw off a ribbon here of flat glass. So we've yet to define the machinery in that area, and yeah, that's something that we're working on at the moment. So if anybody from flat glass has got any ideas on that, please let us know. Okay, I think that covers all the main points there on that slide on forming.
Yeah,
so
I think your cursor stopped working near at the end there, Peter. So do you want to just click again, and you should take control again. Go on, and then click again to go through to the next screen.
Yeah. Has it gone through?
Yeah, it's gone through. So is there any questions on Foreman for Peter from anyone?
Okay, that's good because we're short on time.
No questions now. Okay.
Annealing then. Okay, and challenge is going to be the annealing layer because the glass might be coming in quite cold after the low tonnage output and the long conveyor. So we might need to reheat a little bit more like a decorating layer. But as you can see, at the moment, we've not got too much space. So we're discussing this, and maybe we need to fit at least another section in there. But the main objective we're trying to achieve with the layers, obviously, apart from anneal the glass, is have quite a significant run-out table, so we can fit cold coating testing in addition to the standard testing. So standard supply, equipment, which would be treating the glass. Sorry about that. It's gone. Go back. Yeah, so we will be able to do additional development work here. Currently, the overall length and width of the layer is under consideration. We need to do the calculations on that, but the intention is to give this space here for coatings development work. And of course, for a flat glass, I've mentioned the flat glass, we won't be using this layer. The flat glass layer would be a different layer. This is a container layer. We may well potentially feed in containers from the left-hand, or the hollow glass, whatever that is, not necessarily containers, from the left-hand side we could bring in also. So if we put another forming machine in, the reason we position the layer centrally is so we can bring in that wear and anneal that as well. Probably not at the same time, but as an option. So one layer would do two forming machines. The flat glass would have to have its own annealing layer. Any questions on that? I seem to have lost control again, Robbie, I think.
No,
just slide forward.
Yeah, just click again.
Yeah.
And you should be able to click through. It's not happening. I haven't much luck with this. There you go.
Oh, we briefly went there.
So you want to be there, don't you?
So I think we're on any questions for annealing.
Yeah.
So any questions for annealing?
No.
Peter, I've got a question, Peter.
Yeah.
How easy it is to connect annealing, forming, and the melting process into one platform as a part of a digitalization? Do you think that are there any challenges associated with that, or is it a straightforward process?
Fairly straightforward. We've got the involvement of Siemens, as you know, and we're specifying the equipment so it's easily interconnected. So that's part of the specification of supply, that we have one common technology linking everything together. So absolutely don't see any problem there. The question would be, at what level do we do the monitoring? So maybe we put in additional sensors to what would be normal. Maybe we monitor things to a greater degree than normal. So I don't think the data communication is any problem whatsoever. It's a question of what level do we go to with the sensing, and what's not only what's necessary, but maybe what may be desirable from an R&D point of view. So I don't see any problem there. It's in answer to your question. I think we got that one well covered.
Okay, is there any further questions on Annealing before Peter moves on? No, I think you're good to go, Peter.
Okay, so automatic inspection. Hopefully you can see the mouse still. I don't know. Can you see that, Robbie, at the bottom?
Yeah, yes.
Yeah. So what I'm pointing to there is where we've come out of the layer into the single lines to go through the inspection equipment. First of all, you'll notice that it's a dual line, that quite clearly for 30 tons, we don't need a dual line. But we want to put in a dual line because it gives us flexibility in terms of testing. Again, we're not just a manufacturer, well, we're not a manufacturing plant, we're an R&D plant. So we want to be able to inspect finished product, but also we want to do additional work as well, not just about inspecting, packing and dispatching any product. So what we've got here, if you look at the lines in red, so the conveyors in red there, these are removable sections, and these will allow us to either operate in a production mode or in a recirculation of wear modes. So we're just passing the same wear through the machine, and you can see we've got an inner loop and we've got an outer loop. So we'll have the ability to test two different types of inspection, different containers at the same time there. But also we can have production going on the outer. We could have production going on the outer there to the packaging machine. And obviously these loops would be removed at that time to dispatch the packaging with the AGVs. So, but on the inner loop, we could have this inner loop here operating while we're actually in production. So this loop here would be on R&D mode, and the outer loop, or the outer line, I should say, in this case, would be feeding the packaging machine. And while we're doing this, of course, we can have the communications to the hot end and work on communications development there. And in addition to what you see there, there's absolutely ample offline laboratory space. So just to the right here, down here will be lab space for any kind of offline testing we need to do. And you can see there's more than enough space there for supporting this facility. But we could bring in anybody's equipment, test it, performance test it, put it on a live line or on a simulated line, and put it through its paces in a glass factory environment. Okay, any questions on automatic inspection?
Is there any questions, just to go back to the beginning, is there any questions on forming, annealing or automatic inspection? Because I lost the visual of the chat as Peter was talking, so I might have missed any questions. So if you did type any, could you just repeat them?
I mean, from my side also, just about questions, if there's no questions, any input, if you've got any other ideas. Like I said, at the moment, this is the proposal. It's just on concept right now, and so we would be open to change if you felt you had a need you would like from Glass Futures in forming, annealing or inspection, and you think it's not being catered for, let us know.
Okay.
I just wanted to check from my point of view, looking on the cold end there, say coming out of the layer, I wasn't quite sure. What you said is there is space there for putting in sprays or coating or decorating style equipment?
Yeah, that's not decorating as such. I don't think we have space for that. We have discussed potential of a separate decorating facility a long time ago. We didn't pursue that, but it has been discussed if that's needed, and that seemed to be part of it. We may need to use a mezzanine floor to do that. But for coatings, definitely there's a space. I could go back to the annealing. I'm trying to go. Can you go back a few slides, Robbie? I can't get control. Yeah, go back again. This one here. So if you no, back to where the annealing layer is with the yellow. That one. Stay there. Yeah. So you see the yellow part there. That's the run out table. You can see some cooling fans on there. You can see a duty spray. We could open that up, put in a second spray, of course. That's the area that we want to try to protect. The annealing part is, if you like, the necessary evil. We have to use all that space. We don't want to. We'd rather use that space for processing the bottle, but at the end of the day, you have to anneal the container. If we push for space, we might end up with a wider layer than would be ideal for production, just so we can have a longer, excuse me, a longer run out table for development work, like you mentioned there.
It's just tackling that issue of wall thickness versus strength, maybe with coatings, and the importance that might be going forward.
Exactly. So we want to guard that area of yellow, and to make sure we've got the space to do that kind of work. If I was just interested in good production, I would be putting more layer sections in there, narrower, to get the feedback to the hot end quicker. But I think what we're going to have to prioritize is that area for the development work you mentioned.
Okay. Any further questions? Anything further for Peter?
Just a quick one for Peter. Sorry. Just in terms of, obviously, in normal manufacture, we're all about defect prevention. Is it a case that now we're going to be about defect creation in terms of to test all of the different equipment, to test all of the different operations that we may have on the line? I notice on that diagram there's a QC station on the line. Are we going to man it and control defects, be it in any type of glass manufacturer? What's the thought process on that?
Yeah, it'll be manned like a normal glass plant when we're in manufacturing mode. So we'll be doing all the usual checks. Everything will be done, and that's the point at which we can obviously test all the communications from the cold end to the hot end and gather the data. But in terms of defect creation, I don't know if you've ever tried to create defects. I can make plenty of defects when I don't want, but if I want to make them, it's not always as easy. That's how it works. But yeah, of course, we can do testing on the IS machine, and we're always looking to minimize the defects. So, but yeah, if we need to create defects for testing, then we can create those. However, I would expect more that customers would come to us and say, look, this is a defect we've got. We can't inspect it. We've had a lot of product in the trade. We didn't even detect it. What can you do to help us? And so that would then become a project for working on that particular defect. So it would be more like taking the more challenging type defects and trying to maybe improve existing equipment, inspection capability of existing equipment. We don't really want to be designing from scratch, but spending some time on that and trying to prevent the risk of defects leaving production lines throughout the world, protect the reputation of glass, of course.
Okay, thanks.
I think if I could just kind of jump in there. So I think the idea is that, to kind of add to what Peter's saying, is really we're quite keen to run the projects that the industry needs to improve the industry. So if like Peter says, if there is a certain defect that we want to kind of investigate, or certain area of the production line where we think there's opportunity to improve, this line offers that flexibility to kind of change settings quite quickly. So it's not like you've got to wait 4 hours and lose 4 hours of production before you can see something. There is scope to be flexible, to change things quickly, and then sort of respond quickly as well. And hopefully with some of the digital systems we're putting in, like the ones that Tobias mentioned earlier, we can actually get that kind of quick feedback, and we can actually use some of these experiments to then effectively kind of stress test the production to work out sort of what happens when you push the production to its limits. Do you actually still get stable production, or what do you have to do to adjust the line for that? I think the other thing I would add to that is the kind of flexibility of the line allows multiple tests to be undertaken at the same time. So it might be that someone's doing some test on the furnace, producing glass with it. We can then do parallel tests on the forming section, assuming the glass coming out is okay. And then we can have parallel tests again at the inspection end as well, inspecting the containers as well. So the idea is it doesn't just have to be one project running on the line at any moment in time. What we want to do is set the line up so we can maximize the value of any production run, and therefore kind of spread the costs across different projects as well.
Yeah.
Rob, it's Brian McMillan. Can I just add a point in about the first thing on the inspection? Obviously, the what comes off the machine, and there's plenty of room within the long conveyor for the the up-to-date hot end inspections. And as Rob has already alluded to, that the digitization would enhance the quick learning that would be needed to make possibly even automatic changes to an IS machine. But these are all ideas that could be tried and tested and proven on such a line that's proposed. And just going back to coatings, there is also plenty of space to do development work within the hot end area of container coating, as well as the cold end.
Thanks, Brian. Is there any further questions for Peter on any of those subjects, or for anyone else for that matter? No? Thanks, Neil. Thanks, David, for those questions. Back to you, Rob.
Hi there. Thank you very much, Peter and Tobias. Really interesting presentations there. So just to finish things off then, so hopefully this afternoon has provided a really good introduction to what Glass Futures is, what we're aspiring to do, and hopefully it's also given a flavour of some of the potential opportunities that Glass Futures offers to the industry to actually kind of really make big strides forward in terms of developing new technologies that are going to change the industry. So just to kind of finish off, I think it'd be useful maybe just to kind of outline some of the timelines that are associated with this. So the pilot facility itself is progressing well. We are still at the design stage, as we mentioned earlier. We recently submitted the planning application, and I believe that's progressing quite well. And all being well, I think the line will be fully commissioned and running by mid-2023. So although that feels like a long way away, I'm pretty sure that will come around very quickly. But also, like I said, there are a lot of activities going on in the background. So I know you might be kind of feeling, well, why not just kind of sit back and wait till the line's ready before engaging with Glass Futures? Well, actually, I think there's lots of reasons to get engaged with Glass Futures now. So one is you get to participate in the existing work that's going on, which is extensive. It also provides opportunity to actually not just get the results from the projects, but actually to shape them and even get grant funding or other financial benefits as a result of this work. So again, I certainly encourage everyone to engage with the Glass Futures team if you're interested in finding out more about that. But there's also a great opportunity to influence what happens in Glass Futures. So we've talked about the line itself. There's still a lot of chance to influence what that looks like. So if you have certain technologies or developments that you want to see trialed on the line, please join us. Please show us how we can make sure that facility caters for your needs. Or even if you have expertise that you think would be beneficial for the design team to have just additional insights into what might be possible, or new ideas that we might have just not spotted yet. Again, we're really keen to have all that because we want to make sure this facility really does cater for the entire glass industry. So if you're interested in that, please do come and talk to us about membership. So we do have a couple of different levels of membership at the moment. For those that want more just to kind of sit on the sidelines and see what's happening, we have the affiliate membership, but then there is also an opportunity to get more involved in the heart of Glass Futures and activities and the research. And that would be what we're calling the corporate membership offering is there as well. So again, we're happy to talk to you as to what that would look like, to try and identify which level might be most suitable for you. But yeah, certainly we welcome anyone to come and talk to us. And then finally, just to finish off, is to say that there is another session planned. So at the end of next month, I think just before Easter, the 31st of March, the third of these sessions will be on the topic of people, skills and collaboration. So I think that should also be another fascinating session. So would very much be keen to see you there. And I think going forward into the rest of the year, I think we do want to plan to run these on a monthly basis. So if there are specific topics that you'd be interested in us doing a session on, again, please get in touch with us, because we're keen to make sure that these topics address what the industry is interested in. So we do have that flexibility to shape those as well. So I think that's it from me. That's it from the team. So I just want to thank everyone for attending this afternoon, and also a special thank you to our presenters again. We really do appreciate your input and your sharing your expertise. Very grateful for that. So thank you everyone, and have a good afternoon.
Yeah, Rob, I think Richard Katz was just going to close out the call as well. Yeah.
Sorry, Richard.
A big thanks to me as well for everyone for attending, and thanks for help with the slides, Tobias and Peter.
Can I, yes, as Robbie's just said, thank everybody for turning up, but more than that, to emphasize a couple of points. Glass Futures is a not-for-profit entity. Now that's very significant. We're here for the benefit of the glass industry. We don't have any shareholders. We're not forced to make money. Any surplus that we might make gets reinvested into further research and development. What we're about is collaboration and partnership. We're looking for the industry to come together, and we have already very many members who have come together, both in this country and around the world, to combine their thoughts into better methods of manufacture for all our benefits. And we've got the opportunity here for glass manufacturers and the equipment, the supply chain manufacturers, to work together, to look at latest state of the art, and beyond that, brand new techniques in manufacturing. And I echo all that Rob has just said about getting in touch to learn more about what Glass Futures can help you with and what you can help Glass Futures. The government has chosen to fund us very liberally. The overall project cost is around about £50 million, and the government is tremendously supportive. There's major opportunities for members to receive grant funding, which I say modestly myself, we're pretty good at organizing for our members. And we can carry out the research on your behalf. So don't hesitate to come forward and approach Rob to make certain that you understand and you're not missing out, because FOMO, the fear of missing out, is beginning to really take off in all sorts of spheres of activity. And we're determined to make glass retain its leading position in the world for packaging, for windows, for fiber, and all the way across the entire formulas. So don't be shy. Come and talk to us. Anyway, thank you very much for listening.
Thanks, Richard. I'll make sure a copy of the slides with the contact details gets sent out to everyone, and an invite to the third session also. But if you need anything from us, give us a call or email in the meantime. But thanks for your time, everyone. And have a great afternoon.
Thank you very much.
I'll take care.
Thanks, everyone.
Bye-bye.
Bye.